Okay, I'm going to begin the session. So today I am going to cover dispersion measures. So I'll start with ungrouped data first, um, and we'll take it from there. All right, so I'm going to explain dispersion measures by using an example. So let me share my screen. Okay. All right, just forgive me for my voice and a bit of the sniffles. All right, so let's look at this data that we're given. All right, so what we're told here is that we're given the credit card expenditure of a sample of people. All right, so say a sample of customers. So let's count how many values we have here. Right, so we have 3,200. That's 1, 2, 3, 4, 5, 6, 7. So there's 7 customers expenditure. So that's your n value. N is the number of sampling units, or in other words, your sample size, right? So n is 7, right? So make a note of that. All right. Now, in dispersion measures, basically what you're trying to answer is how spread out or how dispersed your data is. All right. And there's a couple of metrics that we use to assess dispersion. And things that you would most likely be asked is to work out the variance, work out standard deviation, percentiles and quartiles. Those are very common questions, so I'd encourage you to get familiar with this. So in this session, I'm going to show you how to do it when the data is ungrouped, when you're given explicitly the values for each sample. All right, so we've got 7 people, and we know how much they spent. Credit card expenditure. All right, so let's say the first question is to work out the first quartile. Okay, so the question is calculate the first quartile. And you'd always have to interpret this, okay? So that means you can't just work out the value and leave it as is. You have to provide an interpretation in words. All right, so calculate the first quartile. Right? That's what you're told to work out. All right, now the first quartile, what that actually is let's say if you ordered your data, right? And if you look at our data, it happens to be ordered, but just don't bank on it being ordered for your exam or your tests or any assessments. You always need to check yourself that it is ordered. If not, then you need to audit yourself. All right. So what happens is, let's say we ordered our data and we start with the lowest here and we start increasing it. We look at what the next highest all the way to the highest value is. So you have your max here and you have your minimum here. Right. Now what your first quartile, it comes from the word first quarter. So let's just assume it's somewhere around here. It doesn't have to be precise. So this is your first quartile and we'll represent it by Q1. Now what it's asking you is, what is this value such that 25% of your data lies below it? And that 25% comes from first quarter. 1 quarter is 25%. That means 25% of your data lies below this value. And that's what you need to figure out. What is this value such that 25% of the credit card expenditure is below that? All right, so that's what we're going to do. So the first step to work with your first quartile is to find its position. Now, in your formula sheet, you would be given this formula here for ungrouped data, right? You'll be given this formula here. Q1, right, position, right, is equal to n plus 1 over 4. Now, this is just to give you the position. It is not the formula to give you the value of Q1. So you probably have like a POS or something written here, but know that that is for the position. So the first step is to work out the position. Now we know what our n is, it's 7, right? So we're going to plug in 7 into this formula, and what we get for the position is 7 plus 1 over 4. All right, and if you work that out, that is 8 over 4, that's 2. Now what that means is it's in the second position. So since you ordered your data, This is position 1, this is position 2, 3, 4, all the way up to 7. So the second position is here. So that value is 3750. So your Q1, the answer for the first quartile is 3750. So that means, and you need to put this in words after this. So you would write 25% of the credit card expenditure lies below 3,750 rands. We'll assume it's rands since they didn't really specify the unit in this question, but let's just say it's rands. Okay, but the principle is more important here than anything. Right, so I hope you understand that. Right, so that's your Q1, right? And that's how you interpret it. Now, sometimes I'm going to throw a curveball in here, right? So say there's an additional data point, right? Let's say this value is 5,500, right? So let's hypothetically say that there's one more point here, right? That's 5,500. So it'll be the maximum and it'll be situated in the far right. So now that changes things if you want to work out Q1, right? So let's redo it, assuming that there's this value of 5,500. So now we have 8 values, okay? All right, so I'm gonna take this out. There's a point to why I'm doing this, all right? I'm going to put in your n now is 8 because we got 8 data points, all right? So now your Q1 position is 8 plus 1 over 4. All right, and if you work that out, that's 9 over 4. Give me a second. I've got my calculator here. All right, so it's 9 over 4. That gives you 2.25. Right, so it doesn't give us a pretty number like before, which was 2. It gives us a value of 2.25. Right. So now the position is 2.25. Now, to find the first quartile, you have to use both the number in front of the decimal. So you have to use this 2 and you have to use the 0.25 to work it out. Okay, so the number in front of the decimal, the 2, tells you, okay, look at position 2, which is here, right? It's here, which is 3750. So your Q1 is equal to the second number, that's what's in front of the decimal, which is 3750. Okay, because that's the second number here, right? It's front of the decimal. It's a 2, so we look at the second number. All right. If it was a 3, let's say it's 3.25, then we would look at the third number, okay? So because it's 2, we're looking at the second number, which is 3750, and then we're going to say plus, and this is where this decimal comes in, right? The decimal means we're going to take that decimal, 0.25, right? And then we're going to multiply it. Now remember, the position is 2.25. Previously, the position was 2, so we just took the second number. If the position was 3, exactly, we would take the third number. But this 2.25 means it's somewhere in between. It means it's the second number and a quarter. Why I say a quarter is because it's 0.25. So it's the second number plus an additional 0.25 of the length between these two numbers. And what I mean by length, it means it's the difference between 4,200 and the 3750. So it's 42 minus the 3750. All right, and you punch this into your calculator and you can work this out. Okay, this is pretty simple to punch into your calculator. What's more important here I want you to take away is how you actually work it out. Okay, so because you got 2.25, you take the second number, that's what we use this 2 here for, the second number, which is this 3750, plus an additional 0.25. Okay, that's the number on the right of the decimal point, times the length between the second and the third number. Okay, all right, and this is the third number, and this is the second, And if you work this out, you'll get the first quartile. Right, so that's why I put this 5,500 here, because sometimes you can get a not so pretty number for the position, and this is how you would work out the quartile. Right, for the third quartile, it works out there. You do it in the exact same way. The only difference is for the third quartile, give me a second. Okay, I'll take this out as well. For the third quartile, the formula to find the position is different. It's 3 into n plus 1 over 4. Okay, so it's not the same as Q1 position, right? The Q3 position is this formula. But the same principle applies. Whatever value you get, say for hypothetically, right? I don't know what this value is. Let's just say it's 4.25. Let's make it a better number. Let's make it 4.75. Then you would take the fourth number, right? The fourth number plus 0.75 times the fifth number minus, right, minus the fourth number. Right, I encourage you to do this in the exercise, but the same method and principle applies when you're working out the first quartile or the third quartile. Remember how you interpret this, okay? For the third quartile, I'm going to go here, give me a second, move this number. The third quartile is here, right? It's always higher than Q1 because 3/4, third quartile, means 75% of your data lies below it. That's the difference. Okay, so a lot more data will lie below it for the third quartile. All right. The next one, let's work out a percentile. Now, what is a percentile? A percentile, it's basically a quartile, but in a more general sense. That means you can be anything. A percentile can be the 40th percentile, the 60th percentile, 90th percentile, etc. Let's say hypothetically you are told to work out the question is work out the 70th percentile. What is the 70th percentile? Right? All right, so how we do that is we first find the position. All right, so to work the position out, we'll call it, you can call it whatever you want in terms of notation, but I'm just going to write P70 because I know it's the 70th percentile, right? So the first thing you need to do is work out the position, just like how we did before. Now to get the position for any percentile, in our case it's the 70th, so that means 70%. So 0.7, right, times n plus 1. That's how you get the position. So in our case, our n is, remember our n is 7, so it's 0.7 times 7 plus 1. So that's 0.7 times 8, which is, I'll tell you now, 0.7 position, it's 5.6. Okay, yeah, I'm gonna get back there. Here we go, which is 5.6. Okay, so that's just the position, 5.6. Right, now we need to work out what the exact value is. So the same principle applies when you're working at the quartiles. You're going to take the number in front of the decimal, which is 5, so you take the fifth number. What's the fifth number? Well, if you look at it, it's 1, 2, 3, 4, so the fifth number is 4,500. All right, so the fifth number is 4,500. Right, then we say plus, and then we look at what the number is on the right of the decimal, which is 0.6. All right, so it's 0.6 times the difference or the length of the fifth and the sixth number. So between the fifth, so here's 1, 2, 3, 4. This is the fifth number. Here's the sixth number. So you want to work with the length between the two of them. And the length between the two of them is 4,800 minus 4,500. 48 minus 45. In other words, this is the sixth number, and this is the fifth number. Right, and you'll punch this into your calculator. All right, if you do that, you should get, give me a second. Sorry, I think you should get 4680. Let's see. Yeah, that's what you should get. Okay, so if you plug this into your calculator, you should get 4,680. All right, so that's how you find the percentiles. Okay, it's very similar to how you find a quartile, but a percentile is basically just a general percentile. Just think of it this way, right? A 25th percentile, 25th percentile is exactly the same as Q1, right? And a 75th percentile is Q3, right? A 50th, right? 50th percentile, right, is actually the median, because it means 50% of the data is on the left, 50% of the data on the right. That means it's the halfway mark. That's what your median is. All right. Okay, so that takes care of quartiles and percentiles. And now I'm going to talk about the variance. I'm just going to erase this part. For the variance, it is very important that you understand how to use your calculator. Okay, it's going to make your life a lot easier and reduce the chances of you making errors. Okay, I'll illustrate how to do it with a Casio calculator. I don't have a shop, so I would encourage you to get a Casio calculator. It is easier to use in the shop. All right. All right. So the variance is represented by S squared. This is your variance. Okay, and for ungrouped data, you'd be using this formula here. Okay, and how I know how to choose between the blue one, or we'll put in a different color, or the red one, and you can use the same kind of guideline that I use. If you see an F in the formula, then that means you're using frequency. In other words, you're using group data. Okay, frequency only comes into play for group data, right? And in this case, we are dealing with ungrouped data. All right, let's get back to it. So S squared is your variance. And if you got your variance, you can then work out your standard deviation, because your standard deviation is the square root of S squared. So that's just your S, and that's your standard deviation. Okay, know the difference. All right, so let's say for this data we want to work out the variance. Okay, so that means you need to calculate S squared. So you're going to use the formula in blue. All right, and if you look at all the terms in that formula, the first term on the numerator is this here, is the sum x squared. All right, and then to work this value out, you can do it on your calculator. All right, what you would do is, and you follow the steps, okay? What you want to do is, you want to, in your Casio, okay, you're going to press the button mode, and then you're going to choose the option that says stat. All right, it should be option 2, but can be another number. But the important thing is that you choose the stat option. All right, and then you'll see another option that it looks like something like this. It'll be 1 minus var, 1 minus variance. So you'll see something like this, 1 minus var. Okay, that's the option you choose. And so you're going to select that option, All right, and you should see on your calculator, you should see an X column. And then sometimes some of you will see a frequency column, but it's okay if you don't see this. It's not important right now. This will only matter for group data. Okay, so your X is where we're going to store our data. And in our case, the data is what we're given here. It's the credit card expenditure. So you need to store all these numbers into your calculator. Once you do that, your calculator will do all the hard work for you, or the heavy lifting. So the first number you want to store is 3,200. Okay, because if you look here, that's your first number here. All right, so you're going to type your 3,200 in that X column, and you're going to press equals to. And once you press equals to, you'll see that the number gets stored. All right, and then you'll move on to the next row. All right, and the next number you want to store is 3750. All right, and then you're going to hit equals to. And you'll continue in this way until you store all the numbers that you have here. All right, and if you do that, okay, give me a second. So I'll do it quickly. 4,200 equals 4,500. 4,500. Lucky there's not too many numbers here. 4,800. And then the last number is 5,200. Okay, we've stored all our data all the way up until 5,200. All right. Now at this point, you can press AC on your calculator. The only button you do not press is mode. Do not press mode. You can press on or you can press AC and your data will still be there. All right. Now we want to get the value for x squared. And to do that, remember what the sigma means. The sigma means sum. So we're going to look for a calculator for the sum options. So what you're going to do is you're going to press shift. You're going to press the button 1 because it has stat written above it. And then you should see the option that says sum. Right. And you're going to select that option. In my calculator, it's option 3. You're going to choose that and then you'll see the symbol here. And all you're going to do is select that option. If you select that option and you hit equals to, you'll see it'll give you the value. And it's quite a large number, right? So I'm going to write it out here. It's 1, 3, 2, 5, 2, 5, double 2, 500. Okay, 1, 3, 2, 5, double 2, 500. Okay, so that's our sum x squared. All right, so now we've got the first value to put into the formula here. All right. Okay. Then we've got our n that's needed, but we have our n already. We don't need to calculate that. Just simply discounting the number of data points you got. The next symbol you'll see there is your x bar all squared. All right, on the numerator. And that is simply your average, or in other words, your mean squared. So you work out the mean and you can square it. And a simple way to actually do this, right, is to actually just use your calculator, right? You can press AC on your calculator, all right? Now you're going to find the mean, right? You're going to find this x bar. So you're going to press shift 1 on your calculator, and then there's an option that says var. Sorry, give me a second. My calculator, it's option 4, but it might be different in yours, but all you're looking for is option var. And var means variables. You're going to choose the option variables. Right, and if you do that, you'll see there's a symbol here with x bar in it. And see, it does your average for you. It does all the heavy lifting. So you're going to choose that option. In my calculator, it's option 2. And I'm going to hit equals to. And the value I get is this here. I'm going to put it here. It's going to be 4,307 point. And I'm just going to go up to maybe 3 decimal places. It's a good habit to go to 3 decimal places. Okay. 143. 143. That's your average. But remember, you're going to square it. Okay, the value that you got is just x bar. So don't forget the square, which you're going to have it here. All right. Now, I'm going to put all these values into that formula and get my variance. Okay, so I'm going to remove this. Now you're going to be probably wondering, why didn't I square the number? Why didn't I just give the value of this here? Right? But the thing is, I'm not going to do it now because it's going to be a very big number, okay? And I don't want to write that entire number out. The thing is, in that formula, I have x bar squared. So what I'm going to do is I'm going to put all the values in. So for the first value in the numerator, remember our s, the formula is s squared equals sum x squared, right, which is this here. Right, so I'm going to write that out. And the numerator is 1, 3, 2, 5, double 2, 500 minus n, which is n is 7. N is 7. And this was 8 because remember I added that extra number just hypothetically. Right, but in our case it's 7 data points, right, times x bar squared, which is this thing here. Right, so I'm going to write it 4307.143 all squared, and then I divide by n minus 1, which is 7 minus 1. Now if you work that out in your calculator, right, you punch it into your calculator, you get a value of this here. Give me a second. Quite a big number. Okay, it's 443,690. 443,690. 443,690 point, and I'm going to include those 2 decimal points, which is 48.48. Right, so remember this is the variance. Okay, this is the variance. All of this working was to get the variance, which is s squared. If you're asked for the standard deviation, well, that's an easy part now. And it's probably just 1 mark because all the work actually goes into working out s squared. So to get s from it, it's simply just taking the square root of it. So what I'm going to do is I'm going to write it separately. If you want the standard deviation, that means you're just going to work out s. So this is the standard deviation. So remember, this here is the variance, and what I'm working on now is just the standard deviation, which is just s, and that is the square root of this number here of the variance. So it's going to be square root of 443,690.48. And if you punch it into your calculator, give me a second, I'll do that. Square root of 443,690.48, and that is a value of 666.10. I'll make it 3 decimal places, like I said earlier, so it's 101. Right, but you're not going to get penalized if you do to 2 decimals. It's still okay. Right, but definitely don't take it to, try not to take it to 1 decimal. Put at least 2 decimals. I would encourage you to go to 3. Right, it's more accurate. Okay, and that's your standard deviation. Okay, so this session you've kind of covered quartiles, right? First quartiles, third quartiles. You've also looked at percentiles. I showed you how to work with the variance and also to get the standard deviation, right? Please go over this again and practice this. You can use the same data in this example and check that your data answers correspond to what I've done here as a sense check. I would encourage you to do that. But your workbook also has a lot of exercises that you can work through to help in your understanding on this. And yeah, I think that's it from my side. On the next session, I will do the same thing, but I'm going to do it for group data. Okay, so it's different. It uses a lot more formulas than what we've done here, but it's not too complex. All right, but it is important that you understand how to do that. Okay, and I'm going to stop the recording here and shall chat soon. I will make this recording available as soon as possible.